Anyone tell me what's different? What's in these problems that we haven't really seen before? Alex? The little baby number, right? The number that's up. Little baby. So please, if you have not done so, rewrite this in your toolkit or your notes. So the whole expression, the -3 plus the -4, 2 with the baby little 3. And we're going to notate what that is. Do you, Emma, know what we call this? Is that why you had your hand up? It is an exponent. Please write that down. Or another name for it is... Oh, that's because I make mistakes. That's, I mean, if you want the real... Wow. What? There are a few discrepancies between what version we were on. I don't know why when I pulled this up, that it does not correct itself. 312. Sorry, so mine is different than what you have.
Yeah, we don't have -4.
That would be important to tell me from the get-go, especially when I'm copying. -3.
No.
I was totally. Wait, you don't have what? Oh, you just have 4. That's your, okay. So they took out one of the negatives. They probably realized it was overly complicated. So this is just 4. Now, so we know what that's called, right? It's an exponent, or we can actually call that another name. We will use the word power. Now be careful. That does not necessarily mean power as in like how strong. We've talked about positives and negatives and how strong they are. Power, when we talk about exponents, is just a synonym for exponent. But people just started saying powers. Like raised to the 2nd power, 3rd power. They're telling you what the exponent is. Now what does that do? Does anybody know, like if I just had 2 with a bitty 3 up here, or 2 to the power of 3, or 2 cubed is another way people say it. Marvin? Like what does this tell me to do? Yeah! This number is used to represent repeated multiplication. So if you want to abbreviate that, you can just up here say REP for repeated, MULT for multiplication. That says it's really 2 times 2 times 2 because there need to be 3 of them. Does that make sense how my 3rd power told me use 3 2's? So essentially, when we talk about 3 times 2, like we did yesterday, that's like 3 sets of 2, right? 2 plus 2 plus 2. Powers is 2 times 2 times 2. So difference between multiplication and exponents. Multiplication repeats addition. Exponents repeat multiplying. So, what's 2 times 2? 4. What's 4 times 2? 8. So this is really 8. So if we work one step down, this will become -3 plus that 4 didn't change, but the 2 to the 3rd power becomes 8 plus 5. Now this 4 right up against this 8, what is that doing, Nathan? Sorry, you're really tuned in. I see your eyes like laser focused. So what numbers right up against each other? With multiply. So if you want, put the multiplication dot in there if you like it. I like putting it there. It's not necessary, but it helps me remember. We're working down order of operations, right? We did exponents. Now we hit multiply and divide at the same time. Remember, they're the same thing. So I work through. Does -3 change? Does it multiply with anything? No, so it doesn't change. We're on the multiply step, so nothing happens. Guys, I'm hoping that in your notes you are working vertically just like this, because it's what I'm going to expect from your practice. And a lot of us, I'm just going to be straight up with you guys here, a lot of us are getting progressings on our mastery. I'm not totally done, and I don't get back mastery, so I'm done with every single person's, so otherwise that wouldn't be fair. I was just feeling really crummy last night, so I went to bed, but we have a lot of progressings, and I think it's because some of us are trying to do the minimum amount of work in class, and that doesn't help you when it comes to the mastery assessment. So please, if I'm writing it down, it's worth you writing it down. 4 times 8 becomes what? 32, and then the plus 5. Now I have a choice to make. I can solve this in a couple different ways. Francesca, what would be the first thing you would do? Or the next thing you would do on this? Now you can, totally fine. I actually would do something different. I'd combine my good guys. Because, remember the commutative property? I could change the order I do this in. So what Francesca was going to do, what would you get here, Francesca, when you do -3 and a positive 32? Yeah, you get a positive 29. Then you could add it with your other good guy. I might instead add up my good guys first and get 37, then take the 3 away. Either way, we're going to get 34. Now, I want you to try B on your own as your group, but let me ask you something before you start. What is the opposite of a negative? Positive, right? So, what would a negative times a negative turn into? And I'm not looking for an answer, but try B on your own at your group. Follow order of operations, PEMDAS, working down. Solve your parentheses first. Do your exponents next. So work it out. I'll give you at least 2 minutes. Probably more.
It's 21, you're right. No. It's positive.
Fix it. You're good. You're looking weird. Or maybe it's just I'm weird. And you're
Yeah.
So, when we see -3 to the second power, and I saw this on most people's papers, that really tells me, you don't have to write it, but that really tells me do -3 times itself with 2 of them there. So what does -3 times -3 become, Mr. Hopkins?
Wait, what?
What's -3 squared?
Oh,
You just tell me. Now. Everyone grab a calculator if you don't have it. Get a calculator if you don't have it. If you don't have one, try and be nice. The yellow ones are the best. Type into your calculator -3. Hold on. Hold on. Type in your calculator -3, and then down here on the left-hand side, there's an X with a little 2 above it. That says whatever you have typed, your calculator will square. So if you type in -3 to the second power, and hit enter, you get -9. This is wrong. This is wrong. Here's what your calculator did. Hold on. We gotta teach this right now so you don't try to use your calculator on your homework and get things wrong. Here's what I need every eye up here. If you're still playing with your calculator, do it later. I need every eye up here. When you type this into your calculator has learned the order of operations, right? So when I go parentheses, exponents, multiply, divide, what do you think this is going to do first in your calculator? Alex? The exponent. What is 3 squared? 3 times 3, 9. Then your calculator looks at the negative. That's not what we're doing. We are squaring the -3. Here's how you fix that in your calculator. That number gets squared. Try that. Type it in your calculator. Parenthesis, -3 parenthesis, then the square button. Anybody not know where the buttons are, stick up a hand so I can help you. Now it will come up as positive 9. So parenthesis, -3, close the parenthesis, that will X to the 2 button. That is how you split. So, when you enter, that is now... Oh! If you have a blue calculator especially, I think the yellow ones might fix this, but if you have a blue calculator especially, there's a difference. Please stop talking for a second. You're going to need to know this. There's a difference between... I shouldn't rip this down. All right, I'm not going to rip that down because it actually stays on the wall, and I hate when my posters fall off. This button beside the decimal, look at it on your calculator right now, as opposed to the minus, which is by the plus sign, the negative in the parentheses is what we use to make a number negative. So if you were getting an error in your calculator, you were using the minus, not the negative. So you need to use that negative button beside the decimal to make your numbers negative. We do not use the minus to make numbers negative. Does that make sense? Those are 2 different buttons. Marvin, thank you so much, dude. I appreciate that more than you realize. So this becomes 9. All of that to say we get 9. Plus, now really we should have done this first, but I haven't done anything else with it, so it's okay. I can actually do them both at the same time, but I think in my head I did this first and then I did that. What's -2 plus a 5? If I have 2 negatives and I put 5 positives, we get 3. Now what would come next in my process? 4 times 3, thank you, Ms. Labatsky. What's 4 times 3? 12. Add it with not, so now I'm sorry, I'm going to write small. We get 9 plus 12, and what do we get? 21. 21, I hate that number.
I hate that number.
Sorry, I meant to capture that. Any questions on what we did? I gotta follow. Sorry, I cleared that ink. My bad. I meant to capture it. That's all we're gonna do with powers today. Okay, we just wanted to intro it. We wanted you to understand, get some vocab in your head. Exponents or powers are used for repeated multiplying. Okay, tells you how many times you use that number, how many times you repeat with it. So we already processed through 312, but Madeline says, so these look like the same, right? They both use -3 and 4. This should be a positive 4. Don't trust this because it's on the screen. It's wrong for some reason. They use the same numbers, except here my little guy's a 3, there my little guy's a 2. They're kind of in different places. We've got some difference in parentheses. So if a student of yours, or if a friend, a classmate, whoever, said like, oh, those use like the same numbers, right? They'll be like the same thing. What would you say? Not necessarily, right? We got order of operations comes into play, all that stuff. So don't think like, oh, they look the same. Well, they look similar. The biggest difference, though, would be how many terms they have. So expressions, these mathematical things we talk about, are made up of terms. So each time we separate things, we've created separate terms. So -3 is its term on its own. This whole thing turns into one combined number. It's its own term, and the 5 is its own term. So if we went through and wanted to separate out terms, try that with 314. How many terms, and you don't need very long for this, how many terms are contained in 314? When you simplify things, how many different terms do we have? Anyone bold? Anyone got a guess? Doing what we did on the last one? Separate with those plus or minus signs. This tells you right here, terms are broken apart by addition or subtraction that is not inside parentheses. That is not inside parentheses. Patrick? One term or one break? One term? So you think this whole thing is one term? So look for plus or minuses outside of parentheses. Which means to the left of it is a term. To the right of it's a term. That also helps me figure out how to solve. Right, so now that we've identified there's two separate terms, work with your team to solve this. Okay, a couple minutes. You can always stick up a hand and get some help from myself, or Mr. Smith is just out for this week. By the way, Mr. Smith will not be back this week. Tuesdays and Fridays he's out. His wife is having a baby. You look at me like you're surprised. That is actually happening. I'm not making that up. Sometimes I see fighting the brand new book. Sometimes it will just stay that. When you go shut the book, just leave it open and shut the book. If you want, that's an idea. But sometimes you will start to pull out and touch the book, which is better. We got to turn this. Not right now. It's hard for you to see. You. So what do you do physically first? What thing? What calculations do you do first? And you can't just type this whole thing down. 2 times 3. So you have 2 sets of 3 numbers. What is plus and minus? Matt, do you know what math, or will you tell me what math you did first? Okay, my copy's back there. What did you do first when you started solving? The first, so what in the first parentheses did you do first? Guys, you kind of have 2 options here, but technically this should be the first thing you're doing. So that will become 3 times 5 plus 8 plus 2 times -3.
Sorry.
Then we are allowed to do this multiplication. If you did not do that first, cross out some steps that are incorrect. Start back at that step. I'll give you another minute or so. That's the first thing you're going to do, that multiplication inside the parentheses. Miss Gibson, can you tell me your next move? What you do? Well, so we did in this but are we done with this parentheses? We can do that addition, right? So since we're still on the parentheses step, we add that. So before I can actually ever get to this multiplication, now somebody told me, look, I did this first. It doesn't make a difference here. But if we follow the order of operations, we're not allowed to do that until we get rid of all other, not that. I'm going to do that. So we could, and I'll show you why this won't make a difference. We could have done that on its own. But right now we have 3, what's 5 plus 8? 13. Then, now I'm technically allowed to multiply because I've done all my parentheses steps. So now we can do that multiplication, but it doesn't actually make a difference because we're lucky here. And we can do this multiplication too because we do them all at the same time. So what's 3 times 13?
39.
39. 2 times negative 3? Negative 6. Are they on the same team or different teams? Different teams. Who's going to win? Good, guys. How much is left? 30. Oh, yeah, 33. Sorry, I was about to say 36. Don't know why. Pretty hard. It happens. Yep. Questions on this? Now, I want to talk for a moment about the fact, and I forget who it was that told me that they did the 2 times negative 3 first, because the 2 times negative 3 is kind of on its own here. It's on its own there, it's on its own there. It stays on its own. That's why if you did 2 times negative 3 up here, it doesn't really change anything because all you get negative 6 here, and then you have negative 6 here, and then you have negative 6 there, and then so it doesn't really change anything. But technically, parentheses step, there is no exponents. Multiplication step and multiplication step at the same time. Then we add. Questions? Could we diagram this out, do you think? Could we make a model? Yeah, it'd be a little bit more complicated because we have 2 sets of 4 and 5 more. And that set, we have 3 of those sets, but it'd be a little complicated, but we could do this. Move on with your team to, I forget what the question number is, 315. Try each of these. Now with the tiles, it'd be very complicated if we have partial values. So just think through with your team. Decide how many terms there are, and then simplify. So remember, addition or subtraction outside of a parenthesis separates terms. So in C, Delaney, are you able to tell me in C how many terms there are? So we're looking, yeah, because this addition separates, so that's a term. That addition separates, so that's going to be a term, and that's going to be a term. So in A, we have that addition. All right, I'm going to point to all your addition symbols. Go ahead and work through these. If you are stuck or disagreeing or anything, or just want help because your brain is tired today, I'd love to work. True facts, I would love to work. What's that?
You do 3 times 8. What'd you get? How high is your process? 3 and
You may use your calculators. I encourage using your calculators. Just do not blindly trust them. Trust it, but not blind.
Oh yeah, I saw the question.
All right, let's come back together for just a moment. Make sure we're solving these correctly. In A, the first thing that I want to do, Mr. Hilbert, is
You want to multiply 3 times 8.
and we get
25.89.
25.89 then points. Guys, I'm just not 100% today. Then we got to add the 1 still. I got to go with 26.89. So we really have 2 terms here, because when I do that multiplication, this is 1 term and a second term. Then combine, because this is no longer an expression. This is just an answer. An expression is multiple values being combined or being worked with or whatever. So this is an expression. This is the answer to the expression. And now you can still call it an expression, but technically it's just a term now. This is now a single term. Keep working. If you have any issues, raise a hand. You got great help in the room. You don't have just the answer for B. It works the same way as A. So anyone just have the answer? It's the same thing.
Yeah, it's the same procedure.
Say it, Alan. Go for it.
It's the same procedure because you have to multiply before you add. So it's 3 times 8 is 63, and then you add 1.
If you did this addition first, you are not allowed to do that. We have 3 sets of 8.63 and an extra 1 that we get to add on after we multiply. So be careful. B is the exact same answer as A. C is tougher. I'm going to start working it up here with some help. So, Renaud. So you guys move, and then it throws me off when I look at where you used to be sitting. So Renaud, what's the first thing I'm going to do in C? Perfect. We got to do the multiplication, right? No parentheses that need solving. No exponents. I hate mixed numbers. I don't need you to hate them because hate's a strong word, but I hate mixed numbers. What's better than a mixed number, Alan? An improper fraction. So I'm going to take that 3 2/5, and before I try to do anything with it, I'm going to make it improper. So we use that little triangle method where we multiply down to the bottom, bring it up to the top. So 3 times 5, 15, plus 2, 17/5. Then I'm going to double that. So I'm just going to jot that here. I'm going to double 17/5. Now really, I'm going to scratch all this up because we're not doing any of that. I can then write it as 2 as a fraction. Who can remind me how I multiply with fractions? What did you say? Across the top and across the bottom. So across the top, 2 times 17. 30. Nobody? 34 over 5 is what that turns into. So now we have 4 1/3. 34/5. 5. Penelope, do you know what we need to add fractions? fractions. What's really important if we're going to add fractions together? I agree with that. There's one more piece I want, but I agree with that. So 4 1/3, let's make this guy improper. Ah, so we'll need same denominator. So 4 1/3, when I make that improper, thank you, 13/3. So now my denominators right now are 3 and 5, and if we want to be technical, what's the denominator of 5? 1, because everything has a 1 beneath it, even if we don't see it. Working with 3 and 5, what's going to be a nice common denominator? 15. How do I get these denominators to become 15? What do I use? It's a CPM thing. I've never used it till this year. The giant 1. So, what do we multiply by for 13/3? Alex? 5. Really, really close. 5/5. Because 5 on top, 5 on bottom, really remember makes 1. Now, Alex, I know that you were thinking multiply by 5 in both places, but we want to be specific when we say it, right? So as we go through the year, I'm going to get more and more specific with saying things the right way. What do we multiply in my other fraction? Anybody? 3/3, right? Because we're really multiplying by 1. If you want to draw the giant 1 around it, you can. So again, work vertically. This makes your life nice. So I'm going to work vertically with those multiplications. I'm going to notate that we're still working that same problem. 13 times 5. Break it up. 5 times 10, 5 times 3. 65 15ths. Break it up again. 3 times 30 and 3 times 4. You get 102. Now, I did not do anything with my 5/1 yet. What do I need to do with my 5/1? Alex? Multiply it by 15 15ths. And that will actually become 75. This is where people make their mistake. What do I automatically, without barely even thinking, know about my answer? Grant? Denominator is 15. Write that before you do anything else so you don't forget that we don't add those. We need common denominator to start, same denominator to end. Now, what do I do? Grant, you want to take me home? Take it all the way. You want to do it? You can pass. But what do you do now? Just tell me what to do. I'll do it.
65 over 102.
Oh.
The numerator's all out together.
Yeah, the numerator's all add together. So 65 plus a 102 plus a 75. I see a 5 here and a 5 there. I'm going to combine those first. So what's 60 plus 70, or what's 6 plus 7? 13, so put that 0 on the end. Then I have 5 and 5, so 140. Then another 102. I get 242. Of course you can use a calculator, but mine's right there and I don't want to walk there. So. Now, if we need to reduce it, do the division. So, especially if you still have your calculator at your desk, do 242 divided by 15. It will not come out nicely. Now, especially because we see repeating decimal, that's gross. What can we hit to try to see if this will make it into a fraction for us? Patrick?
You put second and hit right up the times 10 and then.
Yeah, second, and then the button right below data, or actually the button right below, or the button that says table. 16 and 2/15. So guys, notice, everyone look at your calculator. Go 3 buttons in, 3 buttons down. It says like times 10 to the n. That button times 10 to the n, right above where my finger is. Notice that above that button, it shows taking a fraction and making it a mixed number, and it's got arrows going both ways. That will convert either direction. Improper to mixed or mixed to improper. So, whichever you want to do, if you want to convert with fractions, use that button. Make your life easier. Know how to do it manually, but use that button if you have the opportunity. That was probably the hardest problem on here. So please make sure that you're aware common denominators are needed for addition or subtraction, and then we keep that common denominator. So we're not going to work all the way through all these. We got about a minute left, so go ahead and start packing up. Get your books back where they go. Get your calculators back. Do not leave yet, but I'm giving you some time to pack up. I know we have some stuff with us today. Thank you. So when I post, hey, give me your attention for just one more second, and by that I mean probably about 12. When I post the answers on Schoology, it's going to go up as like a message posting. You can easily reply to that and start helping each other out. So we're going to get in the habit of, I'm going to put the answers up there, you're going to check them. If you have a question that's just like, hey, I got this on this instead of that, or how did you get this, post it on the Schoology, and if you have a response for your classmates, help them out. I might make that sort of interaction worth some candy prizes. So, now you may take off. If you got everything picked up, and you're not leaving me any presents, you may head to your next class. I do not need any presents today.
What about